In this video, I will be solving an ENGAA physics question. The ENGAA is the admissions exam that all engineering applicants have to take upon their application into Cambridge. And this is a question from section 2 of the exam, which is the advanced physics section. On average, you get about 3 minutes per question for this paper, and there are no calculators involved and no formula books involved. And here we have a question that draws upon physics and mathematical knowledge. We also have options from A to H to choose from. So here we have a block. Let me just get rid of that. We have a block with light that strikes that is incident on this surface of the block with 60 degrees to the normal. It then refracts inside the block to form angle theta with the normal and exits back out. We know that the block is 5 centimeters thick, and we know the distance between the point of entry and the point of exit is 2.5 centimeters. And we are asked to find the refractive index of the block. So immediately it is obvious that we need to calculate angle theta, given that we can, the main equation that we have to use in this case is N1 sine of the angle of incidence, so sine I is equal to N2 sine the angle of refraction. So we can simplify this. Given that the light is entering from F, we know that N1 will be equal to 1. So we can simplify this as sine angle of incidence over here is 60. So sine 60, that is equal to N2 sine of theta. Simplifying this further, we get root 3 over 2 is N2 sine theta. Now, given that we have to find N2, we're going to try and find sine theta from the measurements we have. So immediately, because the dotted line is the normal, we know that it forms a 90-degree angle with the surface. So this gives us a triangle that we can use Pythagoras to solve. So theta, in this case, let's try and find sine theta to make our job easier. So sine is opposite over hypotenuse. We have opposite as 2.5. So let's write that out. So sine theta is 2.5 over the hypotenuse. And because we don't know the hypotenuse, we have to use Pythagoras theorem to find that. So this will be equal to the square root of a square plus b square. In this case, that is 5 square plus 2.5 square. So let's write that in here. 5 square plus 2.5 square. So this will be equal to 2.5 over 25 plus, and simplifying 2.5, we can write this as 5 over 2 whole square, all square root. Further simplification, 2.5 over 25 plus 25 over 4 square root. And we keep going like this. So this will be 125 over 4 until we get to this point where we have is equal to root 125 over 2. We can then, because we can move the 2 up here and multiply the 2 over here, we can write this as 5 over, and root 125 is essentially just root 25 times 5. So this can be written as 5 over root 5, 5 over 5 root 5, which is why we can conclude that sine of theta will be equal to, so sine of theta will be equal to 1 over root 5. Now we come back to this equation. So we have root 3 over 2 is equal to N2 times 1 over root 5. Now bringing this to the other side, root 5 goes on top and 1 comes to the bottom, but that doesn't make a difference. So N2 will be equal to root 3 times root 5 over 2, which is equal to root 3 times 5, all square rooted divided by 2, which gives us our answer for the refractive index of the transparent block, root 15 over 2. And when we look at the answers, we see root 15 over 2 as option H. So H is our answer.